Hello, dear friends. I am Professor Umesh Shelke, Assistant Professor in Chemistry, ASC College, Raman Nagar, Burli, Taluka Polus, District Sangli. In last lecture, we have seen the aromatic electrophilic substitution reactions. In that, we have discussed the general mechanism of aromatic electrophilic substitution reaction and one example of aromatic electrophilic substitution reaction, that is nitration of benzene. We will discuss the second example, that is sulfonation reaction. The reaction involving substitution or replacement of one hydrogen atom from the benzene molecule by the SO3H or SO3 group by the treatment of concentrated sulfuric acid is called as sulfonation. Sulfur trioxide is the fuming sulfuric acid is the electrophile. This mixture is industrially known as oleum. In this case, SO3 and H2SO4 mixture, SO3 alone can act as an electrophile instead of protonated SO3. Sulfonation, unlike other electrophilic substitution reaction, it is a reversible. Sulfonic acid group can be removed by the treatment in the dilute sulfuric acids. Hence, for reaction to proceed in the forward direction, it is necessary that water being generated in the reaction continuously get removed. Here we will see the reaction when benzene is subjected for the sulfonation reaction in presence of oleum or fuming sulfuric acids undergoes sulfonation reaction and it results into the formation of benzene sulfonic acids. As we have discussed earlier, how the reaction is proceeded, the path followed by the reaction can be explained with the help of mechanism of the reaction. So next point is mechanism of the sulfonation reaction. The mechanism of sulfonation involves the following three steps. So first step is the generation of SO3H plus molecule as an electrophile. Here the sulfuric acid acts as an acid. It donates the proton to the other sulfuric acids, so it results into the formation of SO3H molecule with the elimination of water molecules. In second step, formation of sigma complex. It is involved the attack of the SO3H plus on the benzene ring result in the formation of carbocations. So here we can see the SO3H plus ion get attack on the benzene ring. It generates a positive charge on the ring. The aromatic character of the benzene get disturbed by the attacking of SO3H plus as an electrophile. It gets stabilized through the resonance. It results into the formation of canonical structure or resonance structure of that molecule, and it results into the formation of sigma complex. So this positive charge get delocalized all over the 5 carbon atom and it results into the formation of resonance hybrid structure called as valent intermediates. Now the third step, removal of proton from the sigma complex. Sigma complex undergo a rapid proton loss called as deprotonation by HSO4 minus, acts as a base and forms the benzene sulfonic acid and restored the aromatic character of these molecules. So this last step is a fast step and it get converted into the product, that is benzene sulfonic acids. So this is the second example of sulfonation reaction comes under the aromatic electrophilic substitution reactions. Then third example, that is halogenation. So halogenation is an example of aromatic electrophilic substitution reactions. The reaction involving the substitution or replacement of hydrogen by the cation of halogen. It may be chlorine or bromine in presence of Lewis acid is called as halogenation reactions. The main function of the Lewis acid is to polarize the halogen-halogen bonds. Analogous reactions with the iodine or fluorine are not systematically useful because I2 is too unreactive and F2 react too violently. So here, when benzene is reacted with the halogen in presence of Lewis acids, it results into the formation of phenyl halides. So we take the example, that is benzene when reacted with the Cl2, that is chlorine, in presence of ApCl3 as a Lewis acid. Chlorination takes place, it results into the formation of chlorobenzene. So the mechanism of that reaction, how the reaction get proceeds, it can be explained by the following steps. Similar to the nitration sulfonations, the halogenation reaction involves the following three steps. Step first, generation of halogen ion, cation of halogen. Generation of halogen ion in the halogenation requires Lewis acids. So Cl2 in presence of Lewis acid ApCl3 gives electrophile Cl+. Here the Cl2 molecule when reacted with ApCl3 as a Lewis base, Lewis acids, so it results into the formation of electrophile or generation of electrophile Cl+ and the base ApCl4-. So second step, that is formation of sigma complex, is similar as that of nitration and sulfonation. It involves the attack of electrophile on the benzene ring resulting in the formation of carbocations. Once this electrophile is formed, it gets attacked on the nucleus of the benzene ring and it is a slow step and rate determined step. It results in the formation of sigma complex. So that sigma complex get resonance hybridized. So the resonance structure of these chlorination reactions. So the sigma complex is stabilized by the resonance and the resonance hybrid of the sigma complex is called Weyland intermediate. Thus the carbocation form exists in the following resonating forms. So like this structure first, structure second, structure third, resonance or canonical structures. Similarly, the resonance hybrid or Weyland intermediate is generated. Then next step is a removal of proton from the sigma complex to form the product. Sigma complex undergo a rapid proton loss called as a deprotonation by ApCl4- and forms the phenyl halides and restore the aromatic character of the benzene. So this step is a fast. The base which is generated in the first step, that is generation of electrophile, when chlorine molecule is reacted with the Lewis acid, it results into the formation of Cl+ and ApCl4- which abstract the proton from the molecule. It is a first step and it results into the formation of chlorobenzene as a product, as a halogenating product. Instead of chlorine we use the bromine. When bromine is used, then it is called as bromination reactions and the product is bromobenzene. So next example is Friedel-Crafts reactions. So depending on the nature of electrophile used, Friedel-Crafts reaction is of two types. Preparation of alkyl benzene or Friedel-Crafts alkylation reactions. Preparation of alkyl benzene from the alkyl halides and Lewis acid, usually AlCl3, is called as Friedel-Crafts acylation reaction. The carbocations and the electrophile, the role of AlCl3 is to generate a stable carbocation complex. Reaction when benzene is reacted with alkyl halide in presence of Lewis acid AlCl3 undergo Friedel-Crafts alkylation reactions where the alkyl group get attached to the benzene to form the alkyl benzene. So the mechanism, next is the mechanism. The mechanism of halogenation involves following 3 steps. So this alkylation also same steps following as that of halogenation. So first is the generation of carbocation, that is alkyl cation. Generation of carbocation in the reaction requires Levy's acids. Here, alkyl halide when treated with the AlCl3, it results into the formation of alkyl carbocation and AlCl4 minus. So alkyl carbocation is the electrophile generated. Once the electrophile generated, it undergoes second step, that is formation of sigma complex. It involves the attack of R plus on the benzene, that is alkyl carbocation ring resulting from the carbocations. Once this carbocation is attacked on the benzene molecule, it is a slow steps and hence it is the rate determining steps. So it results into the formation of sigma complex as we have previously studied. Resonance structure, the sigma complex is stabilized by the resonance, and the resonance hybrid of the sigma complex is called as Wieland intermediate. Thus the carbocation form exists in the following resonating form: structure first, structure second, and structure third. The fourth structure is the resonance hybrid of that Wieland intermediates. After that, the molecule wants to stability as the aromatic character get disturbed by the attacking of electrophiles. So it results into the formation of next step, that is third step, removal of proton from the sigma complex. Sigma complex undergo a rapid proton loss called as deprotonation by the AlCl4 minus and forms the alkyl benzene and restore the aromatic character of that molecules. So here when sigma complex is treated with a base abstract the proton, it is a first step and result into the formation of alkyl benzene. Similarly, the second Friedel-Crafts reaction, it is called as Friedel-Crafts acylation reaction. The preparation of acyl benzene from the benzene acyl halides and the Levy's acids is called as Friedel-Crafts acylation reaction. The acylinium ion is the electrophile. The role of anhydrous aluminum chloride is to generate a stable acylinium ion complex. When benzene is treated with acid chloride in presence of AlCl3 undergo Friedel-Crafts acylation reactions. So here the R may be methyl, ethyl, propyl, butyl, etc. and X may be chlorine or bromine. It results in the formation of acyl benzene. For example, when benzene is reacted with acetyl chloride in presence of AlCl3 undergo Friedel-Crafts acylation reaction to form the acetophenol. Next is the mechanism of the reaction. The mechanism of the acylation reaction involves the following 3 steps, that is generation of acylinium ion. The generation of acylinium ions, when acyl chloride is reacted with AlCl3, it results in the formation of acyl cation as an electrophile and base as a AlCl4 minus. So this is the reversible process. Then second step, formation of sigma complex. It involves the attack of acyl carbocation on the benzene ring to form the carbocations. So here same as the electrophile is generated is attack on the benzene ring to form the sigma complex carbocation. So once the sigma complex carbocation is formed, it gets stabilized by the resonance. The resonance structures of the sigma complex is stabilized by the resonance, and the resonance hybrid of the sigma complex is called as Wieland intermediate. Thus the carbocation form exists in the following resonating forms: structure first, structure second, structure third, and the fourth structure is the resonance hybrid of that is called as Wieland intermediates. So next is the removal of third step, that is removal of proton from the Wieland intermediate or sigma complex to form the product that is called as acetophenol. So this is the first step. Once this sigma complex is formed, it readily get converted into the product by the loss of the proton, and it results into the formation of acetophenol as a product. So with this we have completed all the units, that is aromaticity, starting from the what is meant by aromatic compounds, types of aromatic compounds, properties of aromatic compounds, structure of benzene, molecular orbital picture of benzene, then substitution or reactions of aromatic benzene or aromatic compounds. In that electrophilic substitution reaction, we have studied the nitration, sulfonation, halogenation, Friedel reaction. With this we will completed this first units. So third units. So thank you very much.